Okay, up until this point, you've been naming your compounds with the name of the metal, the name of the nonmetal, and a Roman numeral if necessary. But there is an older naming system that has Latin roots as its basis. And it's not that I'm going to be asking you to name these on the midterm or on the Regents exam. It's not going to show up beyond this unit's test, except on the names of chemical bottles that appear throughout the year. So sometimes some of the old chemical bottles in the chem supply room are labeled in this format, and for safety's sake, I really need you to be able to pick up the right bottle and use the right chemical for each lab so we don't have accidents. And that's why we're really stressing this topic as part of this unit. This is called the Common Naming System, and it uses root words, which are Latin based, and suffixes instead of Roman numerals to indicate which metal ion you are going to be dealing with in your compound. Okay, the root words, some of them are pretty familiar. The others that you are not too comfortable with are actually the foundation for the symbols that you use, the chemical symbols on the periodic table. The first element is mercury. Its root is mercure, which is very similar. Lead is plumb, and that's because lead pipes used to be pretty much the normal, especially in like ancient Italy. And so you might recognize the word plumb or the prefix plumb from various foreign languages you've studied. It's also where we get plumber from, and it's why lead is Pb. Iron, Fe, is Fer. Copper is Cupr, which is where the Cu comes from. Tin is Stan with two N's. That's where Sn comes from. Nickel is nickel, and then gold is Or, Au. That's where its symbol comes from. When we go to come up with charges or suffixes that are going to indicate the charge for the metals, there's two suffixes to know, ic and us. Ic is only used when you're dealing with the metal and you're using its higher oxidation state. When I say higher, I mean larger, not located higher up in the sequence on that reference table box on the periodic table. So it's not the one that's at the top, it's just the larger value. If I use us as a suffix, I'm dealing with the lower value, meaning the smaller value, and not necessarily the bottom number. The elements that we deal with, the ones that I listed on the previous slide, only have two oxidation states. You will never have to name any other element with this system, and they will not have three values. There is no way to use this system if there's more than two oxidation states. Notice how on this slide, ic and high both have the I in them highlighted to remind you that they go together, and the us and low go together. Okay. The first example we're going to deal with is CuCl2. When we go to uncrisscross them, we know we've got one copper and two chlorides. We can look up the charge for each chloride and see it's a -1. So by default, the copper had to be a +2. This is the same exact technique you use to come up with Roman numerals. If you were to name this with Roman numerals, you would have called it copper Roman numeral 2 chloride. What you will want to do then is to go to the reference table for copper and look up the two choices for the oxidation states. Copper can have a +1 or a +2 value. Since +2 is the higher of the two values, the larger of these two values, we are going to call this cupric chloride. The higher value gets the ic ending. So cupr for copper, ic meaning the higher oxidation state on the copper, and then chloride. There's no need to use a Roman numeral. The second example, SnO. Sn is tin, O is oxygen. We have one of each. So we look up oxygen's oxidation state, which is -2. And by default, that's going to mean tin had a +2 oxidation state. If we look tin up on the reference table, we see its oxidation state choices are +2 and +4. +2 is the lower of the two values for tin. It's the smaller number. So when we name tin 2 oxide in the common naming system, we're going to call it Stan, and then us for low. Stan, us, oxide.